Hi everyone, welcome back to JDCodebase. In this video, we are going to learn how to implement a queue using linked list in JavaScript. Earlier, we learned how to make a queue using an array, right? Now let's see how we can do the same thing using a linked list and why that is actually a better option sometimes. Let's get started. Before we start, let's do a quickly recap of what a queue is. A queue is a linear data structure that follows the FIFO rule, which means first in, first out. So the element that enter first will be the first one to come out. Just like a real life queue at a ticket counter, the person who comes in the line gets served first. Now a queue has some basic operation: queue, dequeue, peek, front, and is empty. Yes. So we already built this using an array before, right? So let's move to linked list. Can make this even better. So let's first understand why we might prefer a linked list over an array for a queue. In array a queue, we have some problem. If we use a fixed size array, we have a limited size. It cannot be overflow. And when we remove element from the front, we often need to shift all the other element one step forward. So dequeue operation can take big of n time, which is not very efficient. But if we use a linked list, all this problem go away. So advantages are the size is dynamic. So it grows and shrink automatically. And we do not need to shift elements. Both enqueue and dequeue takes big of one time. So it is easy to manage using the two pointer front and rear. So overall it is faster and more memory efficient. So let's understand the structure now. A queue using the linked list is basically built using the nodes. Each node has two parts, data and the next value, a pointer that connect to the next node. And to manage the queue we use two pointer front and rear. Front is the which point to the first node used during the dequeue, and rear which point to the last node and used during the enqueue. So it looks like 10, 20, 30, and these are the pointers, the stars, and this null is the last one, and this is rear, and this is front. So here we add a new element, it goes to the rear from here. We connect this from new element, and when we remove an element, it removes the front part from this, means 10, 20, 10, 30. So let's go step by step through the main operation. So first one is the enqueue insert at the rear. First we create a new node. If the queue is empty, both front and rear point to the that new node. Otherwise we connect the current rear node to the new node and then update rear. And dequeue is the delete from front. If the queue is empty, we simply show a underflow message. Otherwise we move the front point to the next node. And if the queue becomes empty after that, we also set rear to null. So with these two operations, our queue works perfectly using a linked list. So let's move to VS Code and see how we can write this in a JavaScript. So first let's create a class for our node. Each node will have a value and a pointer to the next node. Class node constructor, and it takes value, and this dot value equal to value, and this dot next is equal to null. So here value store the data, and this next is linked to the next node. So let's make our queue class queue and constructor, and it takes this dot front equal to null and this dot rear equal to null. So at the start both front and rear are the null because our queue is empty initially. So in the next video we will add all the important methods like enqueue, dequeue, is empty, and test them with some example. So let's quickly summarize what we learned today. Enqueue can be efficiently implemented using the linked list. Both Enqueue and Dequeue works in big open time, and there is no fixed size like limit like array. And it is perfect for dynamic and memory efficient situations. So now you understand how Enqueue structure works using a linked list. So that is for this video. In the next one, we will do the full implementation of all operation in code and test it together. If you find this helpful, don't forget to like, share, and subscribe to JDCodebase for more short and practical